Hello and welcome to this seminar on data science with machine learning and Python. This is Suresh from Segler Technologies, and today our topic of discussion will be machine learning and data science. Before we go to today's agenda, let me ask you this. Have you seen these movies? Do you think these things will happen in near future? Similarly, another question. Is artificial intelligence a threat? If humans can create machines that are more intelligent than us, then it is dangerous, isn't it? Because what happens if the machine decides not to obey humans? Anyway, I leave it to you to find answers to these type of questions. Some history. We started using machines in industries from 18th century onwards. Industrial revolution was an extension of physical power of humans. Things which were physically difficult for humans were made done by the machines. But recently we started another revolution with machines, which is artificial intelligence. Artificial intelligence is an extension of mental power of humans. Let's go to the agenda. First we will try to distinguish artificial intelligence, machine learning and data science. And the next we will see how the world is advancing using the new technologies. Then we will see what is machine learning, how powerful is machine learning, and how popular organizations are implementing machine learning. Then we will understand how machine learning works. And next we see different types of machine learning, how each of them work, how are we using them in day-to-day life. Then we will see what can we do with the machine learning. Here we will find answers to machine learning questions like what will be the price of this house? Is the mail a spam or not? Is this transaction a fraud? Questions like that. Then comes the fun part, a demo on machine learning using Python. In the demo we will create several models and compare their results, and then we choose the best model. And finally, about the course, we will talk about the duration, the schedules, the crash course, etc. By the way, for learning data science and machine learning, there are some prerequisites, and these prerequisites are covered in the crash course, and that is a part of this curriculum. So no extra fees or anything like that. It's included in the course curriculum. Now let's see artificial intelligence versus machine learning versus data science. Let's try to understand what are these. Only then we will be able to distinguish between them. The term artificial intelligence was first used by John McCarthy in 1956. Artificial intelligence, sometimes called machine intelligence, is the intelligence demonstrated by machines in contrast to the natural intelligence displayed by humans. Natural intelligence displayed by humans are like planning, understanding languages, recognizing objects and sounds, learning new methodologies, problem solving, etc. When machines show these capabilities, then we call it artificial intelligence. So what is machine learning? Machine learning is simply a way of achieving artificial intelligence. In machine learning, the word learning means that the machine is getting trained. Training involves feeding enough volume of data to the machine learning model and allowing the model to adjust itself and improve. So a question arises here. Can artificial intelligence be achieved without machine learning? Because I said machine learning is one of the ways to achieve artificial intelligence. So can AI be achieved without machine learning? The answer is yes. But this would require building millions of lines of codes and complex rules, complex data structures, decision trees, so many other things, which is very difficult and almost impossible. So let us stick on to the machine learning. Now let's understand what is data science. Data science covers the practical application of advanced analytics, statistics, and machine learning. It also uses data engineering, that is a preparative step on the data before we do the machine learning or before we feed that data into the machine learning model. Automating machine learning is one of the activities which is coming under the data science, data visualization, etc. Let's visualize all this using a diagram. Please try to understand that these are all interconnected and one is the specialized form of or a subset of another. Here you can see this is this big gray that round is artificial intelligence. Inside that machine learning is there. Then again inside that there is something called a deep learning. We are not using any deep learning libraries here in this course or in this seminar, so but deep learning comes under machine learning, and then overlapping all these things is the data science. Data science contains artificial intelligence, part of machine learning, part of deep learning if we are using deep learning, and it also includes the data preparation, other visualization, all such things. So if anybody is asking you artificial intelligence or machine learning, which is better, that's a wrong question. Similarly, machine learning or data science, which is better, it's a wrong question. Recent advancements. Just to get a feel of how the world is advancing using technologies like artificial intelligence and machine learning. How much we have advanced. In food, a program to predict poverty by Stanford University. It's combining satellite images and machine learning models to accurately predict crop yields. And if they can predict crop yields, they can make arrangements for the logistics and the storage and all sorts of things related to the food and food grains and food supply, and then they can eliminate the poverty. In aviation, many areas are using artificial intelligence. For example, ticket pricing, gate allocation while landing, and several other things. Actually, aviation is one of the areas where machine learning and artificial intelligence was making use of. Several projects are going on, several projects have completed, they have implemented it. Similarly, in education, now robots are teaching the technicians to diagnose electrical problems in aircrafts. In crime, the UK police is making use of artificial intelligence to do the laborious task of analyzing the clues and finding links to crimes. In heavy industry, it is common to use robots in areas which are either dangerous or difficult for human to perform. In healthcare, mining medical records for more useful information leading to better treatment. Huge pile of records need to be searched and then identified similar symptoms and what was the treatment and what was the outcome, all those things. If that is analyzed, then they can be used in the healthcare. Wordsmith is an automated software insights platform. It uses NLG. NLG means natural language generation. It gives companies complete control over transforming data into insightful narration, all at high speed. It can write a description of car. For example, if you can see in this picture, this is a description of this Honda CRV. So if this wordsmith gets all the particular configuration and all sorts of details about this car, it starts generating humanly readable English statements, which is grammatically correct and mimicking any human being has written that. Waymo is Google's self-driving car. The name Waymo is derived from a new way forward in mobility. It was previously named as Firefly. This is K-Max. K-Max is an unmanned helicopter which is able to lift a payload of over 2,500 kilograms. That is more than the helicopter's empty weight. This is commonly used for firefighting and in war zones. Aaron is a painter. Aaron started painting, and these are some of the creations. IBM supercomputer Watson. It claims 1 trillion floating point operations per second. Jeopardy is an American television show. It's a game. IBM's Watson computer beats the superstars of Jeopardy. You can see IBM is with the $1 million prize, and then this guy is Brad, and then the Ken. These are the super genius guys in Jeopardy. They have got only $200,000 and $300,000. Now Google's AI translation tool has done something unexpected. It's very interesting. It was supposed to translate English to Japanese and Japanese to English. Similarly, English to Korean and Korean to English. But it started translating Japanese to Korean and Korean to Japanese without using English as a medium of language. Let's move on to why machine learning. To answer this question, let us see why organizations are using machine learning. Netflix is using machine learning for personalized ranking, page generation, search, similarity, rating, etc. Personalized ranking means ordering of items based on user behavior, like users' previous purchases, his page views, and items added to the cart together, etc. Over 75% of what you watch in Netflix is recommended by the Netflix application. Recommendations are made by machine learning. It uses association rules. That's one part of the machine learning, and we will be covering that in the course. Now, Facebook tags. Facebook uses image recognition mechanism to tag and post images. It recognizes the faces in the picture and suggests who is the person in the image. As a part of a new feature, Facebook will also notify users if someone else attempts to use their photo in others' profile. See, for example, if somebody else is using my photo, then Facebook notifies me that this particular person is using your photo. You can either stop it or you can like it. Amazon Alexa. Amazon Alexa is a brilliant voice recognition software. It is using extremely complex machine learning processes to revolutionize the way we conduct everyday tasks. Here Alexa is being asked to check whether there is milk in the fresh cart inside the smart fridge. Alexa uses machine learning for speech recognition, knowledge extraction, etc. Amazon is highly into machine learning and keep on coming with wonderful concepts and products and things like that. If you want, you can check what is Amazon Echo. That's another similar product. Now spam filtering. Machine learning classifies the emails editing. Spam filtering. Machine learning classifiers can be used to determine editing. Machine learning classifiers can be used to determine spam emails. Here, from the left side, emails are coming into the learning part, and it is already classified that this is not a spam and this is a spam. So this is what the this part is learning, and then that learned model is deployed in the production. When the new email comes, the learned mechanism here will categorically separate each email into it's not a spam or a spam. More use cases on machine learning. In bank, it helps in stopping fraudulent transactions. In travel, predicting flight delays, dynamic pricing, etc. In marketing, predicting lifetime value of a customer churn rate, etc. In healthcare, disease prediction, medication effectiveness, etc. In sales, discount offering and demand forecasting. In multimedia, sentiment analysis, digital marketing. In insurance, claims prediction and fraud and risk detection. These are not an exhaustive list. There are several hundred use cases and application of machine learning. Let us see how does machine learning work. Machine learning provides machines the ability to learn automatically and improve from experience without being explicitly programmed. The keywords here are learn and improve. This is just a high-level flow. There are many other factors and steps and components involved in the process. This first part is getting data, and then second part is cleaning the data and preparing and manipulating the data, doing massaging work, and then make sure the data is perfect to enter into the training model. The third part is training model. It gets trained there, and then the output will be a trained model. And then we do a testing part. We take some portion of the data and then we do the testing on this trained model, and if everything is fine, then we will move it to the production system, and sometimes it according to the performance of the trained model, it undergoes improvement. This diagram is showing the training and test phases. In the training phase, we have the data. Here in this case, this is an image classifier. So images are there, and what is each image? So that's the labels. These two things are there. The images data will undergo feature extraction, and then the output of that one will be features, and then that features will be fed into the learning algorithm. Into the same algorithm, the labels will also come. So the machine will learn here what are the features and what is the label, corresponding labels. And once the machine learns, it is moved to the prediction phase. The trained classifier is here, and then next in the prediction phase we get the images. We don't get the labels because that's production system, we don't know. It again goes through the feature extraction, and then the features are produced, and then the feature will be entering into the trained classifier or given as input to the trained classifier, and the trained classifier, this is the model, this will produce the label. Another diagram showing the training and testing scenarios. The first part is data, and then it undergoes a cleaning process, and after it gets cleaned, it will be normalized, and then whatever data modification, scaling and things like that will happen, and then it undergoes a shuffle, and then it is split into train and test. In most of the cases, 80% of the data will be taken as train, and then 20% of the data will be taken as test. The training data will be used in the machine learning process. Once the model is ready with the training data, then it is used in the prediction phase. Here we are using the 20% test data for the prediction, and then it predicts, and then we measure the accuracy. And if the accuracy is okay, then we will move it to production. If not, then again we will redo the training so that it reaches a satisfactory level of accuracy. Again, one more diagram. This diagram is an overall diagram of the entire process. Here the data providers, from data providers we get the raw data. It undergoes pre-processing mechanism. The data processing tools will be used in this one, and then the final thing will be a structured data. Structured in the sense it is in all ways it is qualified to get enter into the learning mechanism. Here the learning algorithm activity happens. For that machine learning algorithm, several machine learning algorithms will be used, and then we find the best model, and that is a candidate model. Then we again iterate this process to get the best performance with the model, and that model will be deployed as the selected model will be deployed as the golden model. The golden model will be used by the applications for the prediction. Let's see what are the types of machine learning, how each of them work, how are we using them in day-to-day life, knowingly or unknowingly. Basically, the machine learning is divided into three. One is supervised, unsupervised, and reinforcement. In supervised learning, the labeled training data is fed into the machine learning algorithm. When the model is ready, the new data comes and start using the model, and then the prediction happens. In supervised learning, features and the labels are available. Machine tries to understand the features and the corresponding label. Then a set of new data which the model has never seen before is given as input. The model predicts the labels, in this case the name of the flowers, for each test data. These predictions are then compared with the actual labels, and that is how we measure the accuracy of the model. The model will continue to learn many times until it improves the accuracy. It's called supervised learning because it has a field called a label, and we use that label to teach the system. In this case, the first four columns are the features, and then the last column is the name of the species, which is the label. Here the sepal length, sepal width, petal length, petal width of this particular type of flower. This is a type of orchid. Its name is iris flower. So it has, this is the sepal length, this is the sepal width, and the petal length, petal width. These values, the peculiarity of these values will allow the machine learning model to predict if this is the combination of data it gets, then definitely it is an iris setosa. Similarly, another species is there, varies color, and then virginica. So the machine learns from this data. If this is the data combination, or this range of data comes, then that is a setosa, like that. Now another use case, the document the classifier. Labeled documents undergo a feature selection phase and then are fed into the machine learning process. Here we get different type of documents, and then we know that this is what is a document. So that is fed into the feature selection, and then appropriate features will be selected. Or sometimes we combine different features and then make new features. There are a lot of things happening there. That itself is a science. and we in the class we will be taking that one as well. Then it is fed into this machine learning algorithm. Then that's a supervised one. So that classifier or that learned machine learning algorithm is called the document classifier. So that into that the unlabeled documents will be given. The document classifier will perfectly classifies each document as of which type. In unsupervised learning, you don't have a label column, hence no supervisor or no teacher involved. You just have a set of data, like in this case apples, bananas and mangoes. It's an unknown output, no training data set. It's all just a collection of data. The machine learning model has to interpret. It will do the interpretation, and then the data means the peculiarity of the data, the features of the data will be interpreted, and then it is fed into the algorithm. The algorithm will decide how to process that so that it can classify. The processing activity happens here, and then it gets classified. This is the output. In unsupervised learning, another use case is anomaly detection. Anomaly detection can automatically discover unusual data points in your dataset. This is useful in situations like pinpointing fraudulent bank transactions, discovering faulty pieces of hardware, identifying an outlier caused by a human error or during a data entry time. See here in this picture you can see the red circles. This is something wrong here. Though the data is varying, it's the varying data. Within that again there is something, a spike or a change that has happened. There is something wrong there. Another use case for unsupervised learning is what is Amazon is doing. Association mining, that is what Amazon is doing. Identifying items that frequently occur together in the dataset. That's what Amazon is identifying. Retailers like Amazon, Walmart, they use this for basket analysis because it allows them to discover goods often purchased at the same time. See, for example, if you buy bread, then there are high chances of you buy butter or jam along with that. Similarly, if you buy milk, most probably you will be buying egg also. They find products that are seen together in the basket, find the association between them, and next time when a new customer comes, when he buys bread, immediately the other two products will appear to, and this adds a temptation for them to buy the other product as well. That's one. Second thing is it is making the user or the customer convenience, that he doesn't have to search for another product. It is already there, the products that are bought together. Next is reinforcement learning. How about a computer learn to play a video game or drive a car? Reinforcement learning works through trial and error. Here it learns to choose the action that will yield more points or rewards. Here the agent and the environment and the action, it observes and do as a policy, an action. It goes to the fire, it gets minus 50 points. It goes to it's bad, it learns that. Now it will go to the bucket and this water, then it will get more points, more positive points, not the negative points. Like that the machine will start learning to acquire more rewards. It has components, as we have seen, the agent, that's the learning or the decision maker, in that case that particular robot in the previous picture. And then the environment is what the agent interacts with. It is choosing the fire, or it is using that bucket. Then actions, what is it doing, what is it choosing. So the agent chooses the action that maximizes some specified reward within a given amount of time. So that is what is reinforcement learning. So let's move on to what can you do with machine learning. For example, you can ask these questions to the machine, like what is the market value of this house? Is the email spam or not? What type of house lies in this segment? Is there any fraud in this transaction? But to get answers to these, you need an algorithm. And the algorithm that should be used to train the machine. You will choose which algorithm to be used and then when. Depending on the algorithm that you choose, you will get the results, and later you will improve the accuracy, and then you finalize to use a particular algorithm with a particular set of parameters and settings. Let's explore the algorithms one by one. Classification algorithm. When the data is provided, these algorithms will classify the data into categories, like what we have said previously. Is this mail spam or not? Will it rain tomorrow? Is this person a male or female? In this algorithm, the computer program learns from the data provided. After learning, when a new set of data is given, it classifies. Some examples where classification algorithm is used are speech recognition, handwriting recognition, biometric identification, document classification, etc. So depending on the data, it classifies. That's what the classification algorithm does. Next is the anomaly detection. We will be finding the unusual data points. Here aircraft engine features, that is the observations from aircraft engine, is plotted along the heat x1 is plotted along the x-axis, and the vibration intensity is plotted along the y-axis. Finding unusual patterns that are not in the expected behavior. If the data comes that way, then there is a immediate alert will occur, and then if this model is used, then that will save so many damages from happening. Here the x-axis is having the heat, and the y-axis having the vibration intensity. Any data that is newly coming, this green x, this is within this range, so it is treated as an okay. But if a data comes here, that means the heat is very high, at the same time the vibration intensity is very low, then there is something seriously wrong there. This is an anomaly. Either the machine is having a problem, or the data capturing mechanism is having a problem. The engineers or whoever is supervising this should immediately act on this one, and then find out the problem, and then try to solve it. Similarly, another example, like is there any fraud in this transaction? Trying to access from a strange IP address range. You are expecting connections coming from North America and Europe, but you started getting requests from Latin America or Africa or any other part which is suspicious. So you can immediately put alarming things, and then you can stop the transaction from entering into, or that connection request from entering into your network. Is a patient having cancer? Finding strange data in the MRI scan, which is compared with a normal person, then that lead to further investigation, and then they can find whether the patient is having cancer or any health problems. Clustering algorithms, that is another one. It is the grouping of data based on some condition. Retailers can discover distinct groups in their customer data set and then use this knowledge to develop targeted marketing programs. For example, you can take fresh food lovers and then junk food lovers. You can classify the basket uh, into these, and then next time when a customer comes, you can see that in his basket he started buying all fresh food and then vegetables and all. Then you can suggest other products in the same category. Similarly, in junk food lovers basket, when he picks some 3-4 items, then the system can show him more of the same product category which the customer will love to buy. Another one is regression algorithm. Uh, the data itself is predicted. Um, this is used in market value of the house. Is it going to rain tomorrow? What will be the stock price of Apple tomorrow? Actually, regression is one of the most important and widely used machine learning algorithms. It allows you to learn the features from the data. Regression is used in massive number of applications. Stock prices are predicted using this algorithm. Here you can see from the x-axis the data is here, and then y-axis is where it predicts. So next time when you get the data and then it is mapped in the x-axis, and then corresponding it where is it intercepting with this blue line, corresponding a line parallel to x-axis which is touching the y-axis will give you the prediction of y. Now we have a fair idea about the machine learning and different algorithms. How will you decide which algorithm to use and when? Let's do a demo using some of the algorithms to solve a problem. In the demo, we will create 6 different models and compare their results and choose the best model. For the demo, I am going to use the iris dataset. This dataset is very famous and considered as one of the best for a small project to start with. This is like the Hello World dataset for machine learning. The data contains 150 observations of iris flowers. The first 4 columns are the measurements in centimeters, and the 5th column is the species of the flower, the name of the species of the flower. There are 3 types of species: Setosa, Veriscolor, and Virginica. It is a perfect classification problem to start with in your journey to machine learning. Easy to start with and to understand how to load and handle the data. We will use Anaconda, which is a free and open source distribution of Python programming language for data science and machine learning related applications. Anaconda comes bundled with Spider and Jupyter. Spider is an IDE for machine learning development in Python, and Jupyter Notebook is a web-based interactive computing notebook. It's automatically installed when you install Anaconda. Detailed instructions on how to install, configure, and things like that will be provided in the class. So let's start the demo. First we will open the Jupyter Notebook. When you open Jupyter Notebook, it will initially come like this. So here what we are going to do is add a new notebook. So for that I'll go to new and then Python 3. So a new notebook is created. Now these are cells. Here whatever you type, this is the place where you have to write the code, and then if you press this button, this run button, then the code will get executed. It will be showing the output just below that cell, and then a new cell will be formed for you to write the next code. See, for example, if we 5 plus 3, and then if I press the run button, you can see 8. It gives the output, and then a new cell is formed for you to enter the next code. So let's start using that. First of all, to get a feel of how Python works, what I'm going to do is import some common libraries that we might use, and then we will check the versions of those libraries. So what I'm going to do is to make this process easy. I'm going to copy and paste the code which was written earlier. So the Python version code one by one. I'll explain these things. Copy and paste. Okay, this particular statement, we are importing the sys, that means the Python, the base Python version. So what is that version? Then we have scipy, then numpy, the matplotlib, pandas, sklearn. Sklearn is scikit-learn. These are some of the libraries that we will be using in our course to run and to iterate over the machine learning process. Now the cursor is on this cell, so let's run this code and then see one by one it's running. So each and every one, print numpy version, print matplotlib, print pandas, all those thing is printing, and its versions are also printed here. So this is just to get a feel of how this Jupyter Notebook works, and then how the Python libraries are imported. Now before we launch the dataset, let's import all the libraries and modules which we are going to use in this particular demo. So I'll again copy and paste. For visualization, we will be using these libraries. I am copying it and then I am running it. So here pandas has a plotting facility that we could use. The matplotlib definitely we are going to use to plot the data, and then cbone is SNS, is its alias is SNS. Cbone is something which sits on matplotlib, but it gives us more features and more beautiful visualization outputs. This matplotlib inline is a statement, a magic statement, which tells the environment to show the output in that cell itself. So this is normally used in the Jupyter Notebook. So similarly, other libraries also need to be included for processing, for pre-processing. As I said, the data preparation part. That part we are using model selection. Model selection is used for other purpose also, but here we are using model selection. Some of the classes in the model selection we will be using for data preparation process. Then next, the validation. We will be using the validation metrics. We are going to use the accuracy score here in this particular case. So we copy that as well, and we have to run it. Okay, go to the next code. Now here comes the algorithms. So these are the algorithms that we plan to use in this demo. These are all the logistics regression, decision tree classifier, k nearest neighbor classifier, linear discriminant analysis, naive Bayes, Gaussian naive Bayes, then SVC is a support vector machine. So these are the algorithms that we are going to use. So run it. Okay, everything is imported. Our data set is iris data set, and it is available at the UCI site. UCI is University of California, Irvine. So we can either download it directly from that site and then use it in the program, or we can, if it is a huge file and then we are going to do some process before we use it, so, or we can eliminate certain records or whatever it is. So if you have a local version of that which has to be used, then you can use this way. No URL, nothing, just the file name. But only thing is, this file need to be there in the running directory from where the Jupyter notebook was launched. So let us copy this these 4 lines, and then we paste it here. Here URL is the complete file link path. The names are the names of the columns with which we are going to take the data. So there are now 5 columns, 1 2 3 4 5 columns, and these are the names for the columns. Now dataset is created using pandas read CSV method. The read CSV method, you can give the URL and what are the names. Here this is a very small dataset. It's only 150 records, and I'm going to use the internet. So to get the data, it will take some time. The star changes 7, that means the data. Yeah, well, so we got the data. Let's do some analysis on the data before we process it. What is the shape, how is it, how does it look like, things like that. Let's take the shape. The shape will give us the a dimension of the data. Its dimension is 150 rows and then 5 columns. So this is the dimension of the data. Now let's take the next one. Let's see what is the data. We want to see the data. The dataset.head, that head function will return first few records. Normally it will show you the first 5 records. So these are the 5 records, and then the column names as we have given, it has taken, the values are there, and then the species name also is there. So this is how the data is in that file. Let's describe the data and then find out some more details about that data. Including its statistical information. How is it distributed? So you will get the count, you will get the mean value of each column, you will get the standard deviation, the minimum value, the maximum value, and then the 25, 50 and 75 percentiles. So if you plot it in the x-axis, the complete data distribution is in and around what value. So that's what. So the 25th percentile will be touching somewhere 5.1 for this sepal length, and then 50th will be 5.8, and 75th percentile is 6.4. You should understand that the maximum value is 7.9 and minimum value is 4.3, and the 50th percentile is somewhere around 5.8. So this is normally done for checking how the data is distributed. Is it evenly, or there is a big skew there? These are the things which statisticians and data scientists normally check. Let's see how the group is classified. We have that species three values. The Setosa, Virginica, Veriscala. How are they distributed? If you group by that and then get the count, then we will see yeah, it's evenly distributed. All are having 50 each. So not one species is less number of data, so which will make the machine learning algorithm find difficulty in generalizing it. Okay, any record is null. If it is null, then we will have a problem because we don't want null values. So let's run that and then see how many records. So no records are having null. All these 4 plus 1 5 columns are not having any null values. This is great. So let's do a scatter plot on the sepal length and sepal width, and then find out how will it look like. So this is SNS, which is the seaborn, which is running on top of the matplotlib, and then we are going to use the facet grid of function of that SNS. We are providing the data set, we are giving the hue that these are the species, and then the size is 5. Now it's mapped to a plotter with the sepal length and sepal width as the coordinates. Then it's adding the legend also. Let's see how is it coming. See, this is what it's going to show. We have the sepal length and then the sepal width, and then the hue is species. So the species are different. Setosa is in blue color, that means this part. So this part is now completely segregated from these two. The other ones are iris color and the virginica. These two species are mixed. It is the data points are mingled. It's very difficult for human beings to distinguish them. Very difficult to put any calculations or anything like that. That's why we are going to use the help of machine learning algorithms to find out a good come up with a good formula or a model which will allow us to separate it. So next what we will do is, after we have done that one, we will try to split the data. As I said earlier, all the data will be split into 20% and 80%. 20% is for testing, 80% is for training. Before we split the data, let us split the data frame into features and labels. Paste it and then run it. So it has run. So dataset.pop means take out and delete it from the source. So previously or now we have the data with 5 columns. This sepal length, width, petal length, width, and then the species. Now we don't want that other columns, only the species to be going to the because that is the label. So we do this dataset.pop and then species column. So all the values in the species will be moved. It will be moved. It's not copied. It will be moved to the Y label. The balance of columns, those are 4. So that will be taken as X. So this is one of the ways in Python. And in data frames in pandas, how we manipulate the data. So we have run that. Now as I said earlier, we will do the train and test split. As I said earlier, test size is 20.2, that means 20%. So automatically the balance 80% will be going as a train, and we are going to use a seed equal to 7. You can give any number of seed. Seed is the value which the randomizer uses to generate the random numbers. If we are providing the seed values to the random state, here the random state is there. So if that is the case, and whenever we run this, we will be getting the same output. The random numbers generated will be depending on the seed number, and then it will be giving the same random numbers. Otherwise it will be difficult for debugging purpose and also for presentation purpose, showing this value to the senior management, decimal points and the output produced by the random values might change. So we don't want to do that. That's why we are giving a random seed. I am giving 7. If you are going to give 7, then you will also get the same number random numbers generated by the system. Okay, now coming to the model selection. In the model selection, we are going to use one class called a train test split. The parameters are x value and y features and columns, labels, and then the test size is given, it is 20%, and the random state we have given, then stratify equal to y values. I'll come to stratify in a moment. This total thing is going to give the output. There are 4 values that will be returning. One is the x train, the features training value, and then the features test value, and then labels train value, labels test value. So these are the 4 things that we are giving. So for the training purpose, we will be feeding this x train and y train to the training mechanism, and later after that, when we do the testing purpose, we will provide only the test features, and the system has to produce the labels, and that labels will be compared with this y test, the actual labels, for checking the accuracy of that model. So this is the way the supervised learning works, machine learning works. Okay, coming back to the stratify.y values. This y is the label, and then that values are need to be stratified. Stratified means when they do the train and test split, they will make sure that equal proportion of the labels from all 3 species will be present in both the test and then train case. This is to make sure that it's evenly distributed, and then the training is done with a sufficient number of y labels from each species. Similarly in test as well, sufficient number of test labels from each species are present in the test case of this 20% as well. So that's what is meant by stratify. Let's run it. Yeah, it's run. So now we have got the train test split. Now let's find out what is the shape of this train and test. And then run it. Yeah, we have got the X train shape as 120, and the 4 are the 4 feature columns. The 120 is the 80% of 150. Similarly, we will check the test dot shape. So how is it coming? Yeah, 30. The balance 30 is taken for the test purpose. So now building the models. This is we are going to take, as we said, we are going to use 6 different algorithms. So let's make a list of all the algorithms and then append the classes created for that algorithm, so that we can use it in a loop. Here the models is created, it's an empty list, and then into that we are adding these 1 2 3 4 5 6 algorithms. So this is the name, and then this is the model. So that is how it is getting appended. Let's run it. Yeah, now here comes the seed is 7 already. The scoring that what we are going to take is the accuracy. Let's run it. Okay, now getting ready for the actual running. So let's try evaluating each model in a loop. Paste the value. Here what happens is 4 name and model in model. So we have created models, and then we have name and then the model value. So these are all classes created. So each time for each name and model, it runs this loop. Here we are going to use the k-fold. Again we are using one of the functions from the model selection module. It's a k-fold. If you want to know what is k-fold, I'll show you that picture. In the training set, that means that 80%, within that itself this k-fold validation will I do iterations for how many times that we wanted to do. We said, number of splits is equal to 10. That means that many number of times this k-fold validation is going to run on the same training data set, but only difference is for each iteration it is going to change the test fold block into. See, in first iteration, the last box, that means 9 blocks for training, and then the last one for testing, and that estimate is taken here as E1. The second iteration, it will move that, so that means this block, this particular block is taken as the test, and then this and all the other things excluding this was taken as the training. That output will be treated as E2, and then again it moves like that. After 10 iterations, the test fold block will go to the first one. All the 10 blocks excluding the first one will be treated as train in the 10th iteration, and the first block will be used for testing. That also will be taken as the accuracy here, the estimate. So E1, E2, E3 up to E10. What we are going to do is we have to take a mean of this one, all the sum of the E1 to E10 divided by 10 will provide us the mean of the accuracy. So that is the best way of identifying, even if some data is having some skewness, or it's not evenly distributed, or its characteristics are there is a big up and down, whatever it is. But if we do k-fold, then we will get a generalized standardized output that we can expect when the new real-time data comes. So that's k-fold. So we are using that k-fold. So for each the model selection, this k-fold is created for each model, and then it is run. CV result is equal to model selection dot this cross val score. This is a cross validation. Then each model is passed, the X train, Y train is passed, CV is equal to k-fold. That means 10 times, and then this is this model is used here, and the scoring is equal to scoring is at accuracy. So it will be using the accuracy for validation. And then finally in that loop we will be printing the message, that means the name, that means LR or KNN or whatever it is, and then the CV results dot mean. We have got that CV results, 10 results will be there, and then we will get a mean of that one. Also we will print the standard deviation also, so that we can understand to what extent it is going to fluctuate. So let's run it and then see. For each model it has run 10 times, and then the results mean value and the standard deviation are printed here. So LR is having 96, 97, 94, 94, 94, and then 97.5. So I think 97.5 and 97.5, these two LDA and then SVM are performing very well in this data. Remember that it's in this data. If some other data comes for its training, it may work in a different way. It may not give this much accuracy. But anyway, for this data, among all these algorithms, this LDA and SVM are performing well. Both are having standard deviation 0.38 and 0.38. That means for SVM it is going to, we can expect SVM accuracy from the 3.8 should be subtracted, so that means around 94, 94 or 93.5. So from that to adding that means 100. So from between 93 and 1, that will be the accuracy that we can expect from if we are using SVM. So this is to identify which model need to be used. So after finding, this is the place where we are going to decide which model we are going to use. So this is manually we are using. Now we will be doing the real run with the selected the golden model. Which is the golden model? We will use that one, and then we'll again run this one to do the training and testing. Here we are going to use, since SVM is giving us a very good performance, we are going to use SVM. Now let us use SVM to train our entire training data and then test the model on test data, which the model has never seen before. Our 20% test data is not shown to any of this model or any of in this loop or anything. So that's totally new to this this model. So let's create that SVM object and then fit that SVM object with the X train and Y train. That means it is getting trained. Now we will use the prediction, which is svm.predict, and then we provide the test data. It's the 20% test value. We are not showing the Y test, whereas in the training we have provided the Y train for it to learn. But now we are going to challenge this model. You do the predictions for these test values, and let's see how is it performing. So it has performed, it has done that value. Let's find the accuracy. Let's print the accuracies of the predictions that was done by this new model which we have created, SVM, on this test data. So we provide this test data and ask the SVM to predict, and then those predictions are kept in this variable or this array, and then that array predictions are actually compared with the actual labels, and then this accuracy score will compare this, and then it will provide the accuracy. And we got 1, that means 100% accurate. You have to understand that though we have got 1 as or 100% accuracy, this particular data is a very small test data. This may not be the case in the production environment. When you are working, you will have to do a lot of feature engineering, lot of data massaging, null value manipulations, so many things to make the data perfect to get entered into the machine learning process. So that is how we have done. So just a recap of what we have done. We have just identified, just to get a feel of all those things, we have printed all the versions, and then we got all these versions. Now we started importing the required libraries and modules. We used pandas, matplotlib, seaborn, and then we used model selection. Then we have used for validation the accuracy score. We then imported the algorithms. We imported 6 algorithms to play with and then find out. Then we identified from where will we get the data, and then what will we call each column. In our case, we have got the data directly from the UCI edu site, and then we used pandas read CSV function to get the data, and then we kept it in the data set, and then we started working on the data set. What is the shape, how will it look like, what is the statistics that we got, is it all evenly distributed. Then we started checking how the species are distributed, is there any null values in there, and then we even did the plotting of two values, which is sepal length and sepal width, to find out how is the data scattered or distributed. Now we changed the entire full data set into features and labels by splitting it into x and y, and then we did a train test split function to split the data into training and testing, both features and labels, x and y. Then we checked, just cross-checked what is the shape of the train and test data. Then we for the algorithms we created a list of all the algorithms to run in a loop. We are going to use the accuracy, that is what we have done. Then in the loop we use the name and the model, and then we started using the k-fold. Split is 10, number of split is 10, means we are going to split the training data into 10 and then run 10 times. Out of the 10 portions or blocks, one should be treated as test, and then the balance 9 should be treated as the training. And it moves, the block moves through the entire splits, so that the output is a generalized one. All the 10 estimates are we took a mean of that, and then we took a standard deviation also, so we will get a generalized expected accuracy of each of these algorithms. The best one we have chosen is SVM, support vector machine, and then we make predictions with that support vector machines, and then we print the accuracy of by comparing the actual labels and the predictions done by this support vector machine. What is the difference or the accuracy, and we got 1. That means 100% accurate. So this is the demo. And there are so many other things that need to be done in the production system, that those things we will cover in the class. I'll save this with demo program, yes, rename it. Okay, that's the demo. Last and most important item in our agenda, about the course. In this session we will be covering topics like what is this training about, why this course, who should attend, what will you learn, is there any prerequisite to attend this course, what are the crash course topics, duration, who is the instructor, things like that. First we'll go to about this course. What is this course about? Our data science and machine learning course is designed to make you absorb the concepts of data science and machine learning. The training will provide deep understanding of data science and its mechanism. As a data scientist, you will be learning the importance of machine learning and its implementation in Python programming language. Furthermore, we will provide hands-on training and practice sessions right from the beginning. You will be able to automate scenarios using machine learning algorithms. Towards the end of the course, we will also be covering the bonus topics. Why should you take data science and machine learning course? Roles like chief data scientist and chief analytics officers have emerged to ensure that analytical insights drive business strategies. This was mentioned by Forbes. According to KD Nuggets, business will need 1 million data scientists by the year 2020. Gartner says 28% more data scientists will be required in the year 2020. and the salary range of experienced data scientists starts from $110K according to Indeed.com. Who should go for this data science and machine learning course? Developers aspiring to be a machine learning engineer, analytics managers who are leading a team of analysts, business analysts who want to understand machine learning techniques, information architects who want to gain expertise in predictive analytics, Python professionals who want to design automatic predictive models, students who want to start a career in machine learning. Even a BTech student can attend this course. People who are not satisfied with the current job and wants to become a data scientist. Those who are not comfortable with much coding but interested in machine learning and want to apply it easily on datasets. Who want to create added value to the business by using powerful machine learning tools. Who wants to learn more about machine learning. And any data analyst who want to level up in machine learning. All these people can join this course. Now what will you learn in this course? This training exposes you to different classes of machine learning. This course imparts you the necessary skills like data pre-processing, dimensionality reduction, model evaluation, and also exposes you to different machine learning algorithms like regression, clustering, decision trees, random forest, naive Bayes, support vector machines, etc. etc. After completing this course, you should be able to automate data analysis using Python, learn tools and techniques for predictive modeling, good command over machine learning using Python, have a great intuition of many machine learning models, make powerful and accurate predictions, workflows and pipelines in machine learning, make robust machine learning models, create added value to your business and career, handle specific topics like NLP and recommendation systems, handle advanced techniques like dimensionality reduction. You will be able to know which machine learning model to choose for each type of problem, and you will build powerful machine learning models and know how to combine them to solve a problem. We have included few topics as a bonus, and they are the common mistakes that data scientists make and how to avoid them, commonly asked interview questions and answers, few cheat sheets for quick reference. We have included a crash course to level you up and to make you comfortably absorb the machine learning concepts and techniques. And finally, you will be getting a textbook on machine learning, a PDF version of the textbook. Are there any prerequisites for attending this course? No prior knowledge is required. Our crash course will lift you to the required level. The software works on Windows, Linux and Mac machines, but Linux systems are more preferred because in the advanced course you will have to work on cloud-based stout Linux servers to process huge volume of data, sometimes even distributed data. These are the crash course topics that we will be covering. One is Python. Python is the base programming language that we will be using throughout this training. We will be learning NumPy, and that will allow us to make nice actions with arrays and mathematical operations. Pandas will be used for converting data into data frames for conveniently processing in algorithms. Matplotlib will be used for visualizing data graphically. Scikit-learn is the important library that we will be using for data preparation and machine learning models. Now about the instructor. My name is Suresh and I have around 28 years of experience in the field of information technology. I started my career as a software engineer in 1990 and worked on various platforms, frameworks, methodologies and strategies. During my career, I have worked in various countries, companies, domains, and I have taken many roles. I am currently focusing on providing data science solutions and training. Now the duration of the course. It's a 40-hour intensive training. It contains theory and hands-on. We will be having code-along sessions. We have flexible timings. We have weekdays and weekends. We have morning, daytime and evening sessions, online and classroom sessions. You may reach us using these telephone numbers, or you can send a mail to training@segler.co. Visit our website training.segler.co and find more about this course, more about what we are doing, and then you are all welcome. Thank you.